Good morning, everybody. Thanks for having hosted me for my first ACI convention. My name is Davide di Summa, and I'm joint PhD student between Ghent University and Politecnico di Milano. And today, what I'm going to present is a study referred to about how to enhance the sustainability of UHPC thanks to the replacement of virgin aggregates with recycled aggregates. Also assessing a specific real large-scale case study. But prior to present our research, I want to address your attention on a report which has been written quite recently by the United Nations, where it is clearly stated that because of the pollution worldwide, actually, there are some zones in the world which are defined as sacrifices zones, where people suffer of the lack of basic human rights. So if you want to read more details, you can scan this QR code. But actually, what I want to highlight now is that that problem has a worldwide size dimension. And this means that whenever we do talk about the sustainability in the construction sector, we are also directly talking about the social responsibility of all of us as part of that construction sector. And so the next step could be to ask ourselves, what can we do during our daily work to improve the sustainability of such sector? I usually make this joke. This is a very iconic skyscraper, which is based in Milan, and it has been designed by Stefano Gueri. So maybe a solution could be to cover whatever with some trees, or well, it could be part of the solution maybe, but since we can be more smart, we can maybe think and discuss about the fact that there are solutions which could be defined as more sustainable than others according to the specific boundary conditions. And actually, we can quantify that sustainability in terms of environmental and cost sustainability thanks to the use of some methodologies, like the life cycle assessment analysis and the life cycle cost analysis. So prior to present the case study, what we did was to characterize the material. So we started crushing a 4-month-old UHPC specimen, actually getting some grinds between 0 and 2 millimeters size. And after that, following the mixed design, which is displayed on the right part of this slide, we obtained the UHPC, where we did replace alternatively 50% and 100% of recycled aggregates. Then the specimens, which are the sizes which are here displayed, 160 millimeters, 40 millimeters, and 40 millimeters of height, were then cracked. And then we did repeat the sorptivity test just to understand what happened within a certain amount of months. In this regard, it's important to highlight that the healing environment, because we also added the crystalline admixture in such mixed design to not only improve the water permeability, to reduce actually the water permeability of concrete, but also to favor the self-healing characteristics of the matrix. So the healing environment of this study was 4 days wet, 4 days dry, and then we tried also to replace the water every month almost. And we also recracked some specimens to check what was the repeatability of the self-healing properties within the time. What it's important to highlight, what we did observe is that in comparison to the reference solution, I mean the UHPC1 without any kind of recycled aggregates, where we did observe a reduction in terms of water uptake up to 3 months. So that 50.9%, which is in blue, is referred to the UHPC up to 3 months. Actually, for the UHPC containing recycled aggregates, it was possible to observe a reduction in terms of water uptake up to 6 months. So in this sense, we are not only acting in terms of sustainability, replacing part of the virgin aggregates with the recycling aggregates, but in our mind, if we also enhance the self-healing properties of such material, maybe we are also acting in terms of durability, in favor of the durability of the material, and then in a direct way, we are also acting on the sustainability of a specific structure. So the case study that we did assess was a geothermal water basin, whose layout is the one here displayed. The geothermal water basin is a structure which has been actually realized in Middle Italy, close to Florence, more or less. What we did was to compare a structure made, in this case, with ordinary Portland cement concrete to a one which was made with UHPC. And as you can see here, it was possible to pass from a cross-section, for the case of OPC, equal to 40 centimeters of the wall, up to a cross-section which was even 10 centimeters thick, but actually the structural scheme that we did adopt for the UHPC was made of several slabs, which were supported by some columns which were made by OPC. So, by the way, I want just to highlight that we did pass from 40 centimeters to 10 centimeters. But how was it possible? This is really interesting, actually, and this is what we want to stress with our daily work, because it's important to talk about also the durability assessment design, because nowadays, if we only follow the standards, there in the standards we can find some prescriptions, like the minimum water to cement ratio, the minimum cement content. So if we do consider, for instance, the UHPC, according to the minimum cement content, considering that in that case we did have 600 kilograms per cubic meter of cement for UHPC, of course we are already in line with the standards. But maybe we can do something more, because the problem is that most of the standards, they don't really include some of the durability models for such advanced cementitious materials, especially when they are exposed in a specific aggressive environment like the geothermal water, where, as you can imagine, the main aggressive agent are the chloride concentrations. So in this sense, just to explain how much importance are the durability parameters, it's important to present a case which is referred to the penetration of the chlorides into a specific matrix. And to make such calculation, we usually employ the second Fick law, where there is a coefficient, the chlorides diffusion coefficient, that can have several values. In general, for the case of ordinary Portland cement content, we get a value equal to 10 to minus 10 square meter by seconds. And for the case of UHPC elements, we can take into consideration a value which is equal to 10 to minus 13. Actually, those values, when we do make the calculations, can really make the difference. And whenever we do calculate the performance of the structure in terms of durability within the service life, we can easily understand what is the importance of the durability behavior of a material. So to develop the analysis, we supposed that each basin, both the one made with ordinary Portland cement concrete and the one with UHPC, each basin was characterized by 50 years of service life. And then we also supposed to get the recycled aggregates on site, thanks to a machinery which has been studied in previous works by other colleagues. And this is really interesting because, you know, whenever we do assess whatever in terms of life cycle assessment, if we also have to include the transportation's environmental burdens, maybe the outcomes can change. But actually, this is the possibility to crush the aggregates and in the same place where they will be employed, maybe can enhance the sustainability of the material. So that's why we did take into consideration this scenario. And for the case of the concentration of the chlorides, we did take into consideration 10 kilograms per cubic meter. Since we assessed all the environmental burdens, including the ones referred to the recycling phases, the ones referred to the maintenance activities, it is important to highlight that all the scrap elements, according to the current European standards, are considered as recycled. And in order to predict whenever it was needed to develop such maintenance activities, we didn't give just numbers in a random way, but actually we did take into consideration 20% of corrosion for the steel bars for the case of Portland cement concrete, while for the case of UHPC, we considered as a serviceability limit state the length which was loaded divided by 200 as a deflection limit state. And at the end, what we did obtain was that for the case of ordinary Portland cement concrete, it was needed a maintenance activity every 3 years, while for the case of the UHPC, we didn't need any maintenance activity within 50 years of service life. This also thanks to the chlorides diffusion coefficient that we did present before. So basically, this is a scheme that can summarize what we did assess. So for the case of the UHPC matrix, we considered the penetration of the chlorides. Of course, the constitutive law changed time by time according to the penetration of the chlorides. And on the bottom part of this slide, it is presented also the moment where when the bending moment is equal to the resisting moment. So as you can see here, it's reached after 62 years in the case of one wall of the structure, and after 68 years in another case. So by the way, so it's never reached the moment when the acting moment is equal to the bending moment. So at the end, just to present the outcomes, we developed the analysis considering 10 impact indicators, and as you can observe here, for the photochemical oxidation and the abiotic depletion, if we do compare the environmental performances of UHPC in comparison to the OPCC, in that case the UHPC performs not better. So I wouldn't define this bad news actually, because at least now, thanks to the sustainability analysis, we understood that there is something on where we do have to act to improve the sustainability. And when we went into detail to check why the abiotic depletion was worse in comparison to the ordinary Portland cement content, we found that it was because of the presence of silica foam. So for the future studies, we do know that we have to optimize the mix design, and maybe we have to understand how we can replace the content of silica fuel. And in terms of economic sustainability, including also in this case all the maintenance activities within 100 years of 50 years of service life, as you can easily understand here, it's possible to save around 90,000 euros in total if we do compare the UHPC in comparison to the ordinary Portland cement solution. So this is just the beginning. We can start to tell to the customers that within 50 years, that is even better than 100 years of other studies. In 50 years, it's possible to save some money. Of course, what we want to reach at a certain point is that we are able to demonstrate that the use of UHPC starting from day one can be more convenient in comparison to the ordinary solutions, even taking all the considerations referred to the durability. Just to give you an example about how it is quite important to develop a sustainability analysis, I used to present this slide. Actually, if we think to compare the electric scooter to a service like the car sharing service, and if we try to decide which option is more sustainable than the other, maybe we can, all of us, agree with the fact that the electric scooter is more sustainable than the car. But the problem is that whenever we do shape in a proper way, considering all the durability parameters, all the service life parameters of the electric scooter, considering the fact that most of the batteries of the electric scooter car sharing services are usually collected in the city centers and are then moved out of the city center, and then there they are charged, and then they are brought again to the city center to replace the old batteries. In that case, actually, there is no difference in comparison to a car sharing service. And sometimes some studies also underlined that the car sharing service considering how the electric scooter service is usually shipped, could be more convenient. So this is just to highlight how it is important to develop a sustainability analysis to really check the sustainability of a specific product, material, and whatever, and how it is important to shape in a proper way our analysis. And just to conclude, I want to give some shower thoughts. So first of all, the key role of the durability and of course of the self-healing technologies, because improving the self-healing, we can extend the durability, we can reduce the maintenance activities, we can reduce the cost, and also we can reduce the environmental burdens. Durability assessment design used also to minimize the maintenance activities within a specific service life, which we do assess starting from the beginning. The use of recycled UHPC, thanks to the reduced maintenance activities, can allow to achieve important improvements in comparison to an ordinary solution. It is important to pass from the lab scale to the large scale case study, because otherwise we will never convince the market that we are going to propose something which is convenient. This is something that happens in my life every day with my students or with my colleagues from the university. They always used to ask me, but why do I have to use UHPC if it is not yet very well developed, or if there are some standards that already include the use of ordinary Portland cement concrete. And of course, the importance of life cycle assessment analysis, life cycle cost, that can not only predict what will be the performance in the future of a specific mix design, but can also provide today a solution for what will be the future needs of the customers that we are going to satisfy today. Thank you for your attention.